So this is where we kicked off last time, and now we're going to do some examples, because as I said in the last one, I'm coming back to this, and it looks quite messy, and there's lots going on and cast. So let's look at the next 4 examples that are in the workbook, and we're going to work through them and just keep referring back to these same ideas again and again, this cast, and this Cartesian plane. And let's see. I'm really hoping that these will start to make sense as we've gone through the 4 examples. Pause during the video. Really push yourself, in class I would say. Okay, so pause, give it a go. If you get it wrong, who cares? That you're learning more than just sitting waiting for me to show you how it's done. So let's read through it. P is the point minus 12, 5. And OP makes an angle theta with a positive x-axis. Determine sine theta, cos theta, and tan theta. Okay, so what's going on here? We've got a point on the Cartesian plane. Let's draw the Cartesian plane. It's a nice starting point. So I'm going to draw it here on the right-hand side. Just checking that my big head's not going to be in the way. X and Y. Okay, so we've got our Cartesian plane. And we've got a point. P is the point minus 12, 5. Okay, which quadrant are we working in? To be honest, I don't even think, I need to put the point in, then I can see which quadrant we're in. So we're at minus 12 and 5. Doesn't have to be to scale, but let's draw it vaguely to scale to know it's more left than it is up. So let's put it over there. And the reason to do this is if we have to work out theta, it's going to look a little bit, fit in better. Okay, so there's our point. OP. Now you might be asking, I know that this is point P, and let's label it minus 12, 5. Where's point O? By convention, O is the point 0, 0. It's the origin. So, the origin. So there's the origin there, O. Okay, and it says that it makes an angle theta. So angle theta. So this angle here is theta, they're saying. I'm going to put it inside. Okay, so it's kind of how we expect it. There's theta. It fits in with the other diagrams. Determine all our trig ratios that we know so far. Okay, so let's start going. We've got our diagram as a starting point. We dealt with triangles. Let's draw a triangle. So I'm going to drop down a perpendicular over here. So we've got a right angle triangle. This is our x value. How far left have we gone? We've gone left by 12. So our x value here is negative 12. This distance is 12, but it's negative 12. Okay, and this distance over here is 5 because we've gone up by 5, but our y value is positive 5. Our x value is negative 12. Our y value is positive 5. What's our r value? Well, if you look at this, the previous video said, well, we've got a right angle triangle, and who always helps us? Who's our dear buddy who helps us with right angle triangles? Pythagoras indeed. Okay, so Pythagoras is there. So Pythagoras says that that squared plus that squared equals that squared. Okay, so we're dealing with r, so I'm going to say 5 squared plus 12 squared equals r squared. Pythagoras. And I keep hitting this button. Pythagoras. And notice that if we had written in negative 12 squared would still give us a positive value. So it doesn't really matter. That squared plus that squared equals that squared, or x squared plus y squared equals r squared. Okay, 5, 12, r equals 13. Nice Pythagorean triple, but of course, calculators, because this will help us just get to the answer. Okay, so r equals 13. I'm going to put it in the diagram. Just like with geometry, as soon as we find something out, let's throw it in the diagram. We've shown our reasoning. Now we can always use it. So we've got x, we've got y, and we've got r. What some people like to do is they'll write here x equals minus 12. Make sure that minus comes out. Y equals 5, and r equals 13. So that it's all here readily available. For this one, I don't know why. I personally like just having it in the diagram, so I'm always looking at the diagram. But this can work really well as well. Okay, so anyway, what are we trying to find out after all of this? We're trying to find out sine theta, cos theta, and tan theta. So sine theta equals, now remember, from our SOHCAHTOA, so SOHCAHTOA, we've got, sorry, got Albert being a bit silly always, right? Sine theta is opposite over hypotenuse. But there are no opposites and hypotenuses here. There is an x and y and an r. So I said always imagine this first quadrant. If theta were here, the opposite would be this distance here, which would be our y value. And the reason I say look in this quadrant, because this isn't theta, remember? Theta is this angle on the outside. So if this triangle on the outside here, the opposite would be the y value. And the hypotenuse is always r. Okay, so sine theta is y over r. Well, we know what y is. There it is, it's 5. Or we wrote it here, it's 5. So I equals 5. R equals 13. So sine theta is 5 over 13. Interesting that it's also a sine of this angle over here. Okay, cos theta. Cos theta from SOHCAHTOA is adjacent over hypotenuse. Now, if the triangle were here, we'd say the adjacent is this one here to do with x. So it's x over r. X over r, because it's adjacent over hypotenuse. The adjacent side is the x value now. And we know what x is. Minus 12, there it is. And we had written it down here, negative 12. But we know we're dealing with this theta and this point. Again, r hasn't changed. R is still 13. So cos is minus 12 over 13. Let's just check. Remember I was talking in the first one about some things being positive and negative all over the show. From our cast diagram. So if we were to write in our cast, we'd have written everything's positive here. A. And then so we went cast. C-A-S-T. Some people say all stations to Cape or something. I don't know. But cast is what we normally say. So let's just stick to cast. So the only positive ratio should be sine. Because we put an S here saying that sine is our positive one. Look, sine was positive and cos is negative. So we expect tan to be negative because tan is only positive down here in the bottom left and everything is positive in the top right, quadrant 1. So let's squeeze this in here and say our last one is tan theta. Tan theta is equal to opposite over adjacent. Now, if the triangle were here, our opposite is the y value. And let me just, because some of you probably think I'm nuts, what am I talking about there? I'm referencing this diagram we drew to say the opposite side has to do with y, and the adjacent side has to do with x. So this is what I always keep in my mind to go, I've learned the SOHCAHTOA, and now suddenly you're going x, y, and r. Now, some of you are saying, also, you're silly, I can just remember sine is y over r, cos is x over r, tan is y over x. Maybe you just remember it. Some of you remember this, shade your rear because x-rays tan your x or whatever, I can't remember the thing. But you've got another mnemonic that you could remember. I always like to think SOHCAHTOA is a one mnemonic. Those are things that help you remember things. And I know that one, and then I can turn it very conceptually, very quickly into this diagram that I can scribble really in a jiffy to go, tug, let me draw my triangle, therefore the opposite is y and the adjacent is x, and it reinforces this triangle on the Cartesian plane. That's why I like doing it that way. But nothing wrong with when you use it enough times that you just remember which one's which. And as I said, there's a mnemonic, shade your rear because x-rays tan your exterior. But I really like this idea of just draw the triangle here, there's the right angle, here's the opposite. So the opposite is up and down, it's vertical, it must be y. The adjacent is here, so it must be x. And r is our hypotenuse. And it's really reinforcing. Okay, so where were we? We were finding tan theta. It's just so exciting out of all links together, isn't it? So we've got tan theta. Now tan is opposite over adjacent. Remember I was saying opposite is this guy here, the y value, and the adjacent is x. So it's opposite over adjacent, it's y over x. And our y value here, we can read it off as 5, or we wrote it here, is 5. And our x value is negative 12. So it's 5 over negative 12. should be negative because sine's the only positive thing here. Yes, it is negative. Okay, and that's how we're going to do those. Next one's, yeah, well, we're just going to keep at it. Let me not waffle too much further, right?